All right, welcome to lesson 11. In this lesson, we're going to be learning about adding fractions and then inscribed angles. Adding fractions, yes, you could do it in your calculator. The only problem is that we are now to the point where our fractions are not going to include just numbers. They're going to have letters in them too. So in this case, calculator's not going to help you. You're going to have to actually learn the concept. So let's get to it. When adding fractions, step number one that we have to do is we have to make sure we have a common denominator. If we don't, we need to find one. So in this case, I have b, x, and 4. None of them have anything in common. So when I'm selecting my common denominator, I'm going to have to include all of them. So my common denominator is going to be 4xb. So now, knowing what my common denominator needs to be, I need to visit each fraction on its own and see what is the denominator lacking. And in this first one, it has the b, but it's missing 4x. So I need to multiply 4x to this problem. But I can't just multiply 4x because that's what I need and I just want everything to be convenient and cater to me because that's what I need. We have to work to keep this a balanced statement. So I can't multiply it by 4x, but I can multiply it by 1 because anything times 1 is itself. So 4x, that does not equal 1, but 4x over 4x does equal 1. Something over itself, something divided by itself is 1. So if I multiply AB by 4x over 4x, I have not changed the value of this problem, just the way it looks. So 4x times A is going to be 4ax, and then 4x times b is going to be 4xb, which is what I want. Then I'm going to say plus, and I'm going to look at the second fraction. What is this second fraction missing from its denominator that will get my common denominator? It has the x, it does not have 4 or b. So I'm going to multiply it by 4b. But again, I can't just multiply it by 4b because that's what I need. I have to work within the math rules. I can multiply it by a variation of 1. So I can multiply it by 4b over 4b. So 4b times c is 4bc. And then 4b times x is 4xb, which is what I was looking for. Now I'm going to look at the last one. I have my 4 in my denominator, but I'm missing xb, so I'm going to multiply by xb over xb. And I'm going to bring down this plus sign, and we end up with xb times d plus e. So the instructions wanted me to add all my fractions together, and right now I do. I have everything over one denominator. From time to time, you will have one extra step past this, where you have to distribute xb to both of these parts. In this case, we don't have to, because I won't be able to add any like terms in my numerator. If there was a like term after distributing, then I would have to distribute to simplify it further. But in this case, there's nothing that will be added. There will be no like terms, so I can stop here and I'm done. So let's do some actual practice. Okay, so in our first practice problem, we have 3 denominators, and this is different from our last problem that we just did because these do have some similarities. So here I'm actually going to not have to just rewrite all of this in my denominator. So let's see, what should our least common denominator actually be? So this is the only fraction that has a 2. So I'm just going to write 2. But every single fraction has 1a. It has a to the first. So that's great. They all have that in common. So I only need to write it once. And then I have to look and see how many x's. There are no x's. This one has x squared, this one has x cubed. So I need to add, instead of writing x to the 5th, I only need to write which one is my greatest exponent. Okay, and we're gonna see why in just a second. So now we need to work on changing all of our numerators so that way we can get all of this stuff under 1. So looking at the first fraction, I have to ask myself, what is 2a missing to become 2ax cubed? And it's missing the x's. So I'm going to multiply by x cubed over x cubed, and that's going to give me kx cubed. Plus, And now let's look at the second fraction. The second one is missing 2. It has an A, and it has 2 x's. It's just missing 1, right? Because it is x squared, but we have x cubed, so there's just 1 x. So 2x over 2x, and then 2x times BC is going to be 2BCX minus, and then this last fraction, all it is missing is 2. So I'm going to multiply by 2 over 2, which will give me minus 2n. So I'm looking at my numerator. Are there any like terms? And there aren't. So I leave this as is, and I'm done. Okay, in this next one, we do have something a little bit different. Our second term is a whole number. So we need to put it in fraction form. So anytime we have a whole number, we put it over 1. Okay, so now we're gonna look at all of our denominators and see what do we need to have for them to all be in common. And I noticed that this is the only one with an A, and then this has a K, but this has K squared. And so that's it. That's going to be our common denominator. So looking at this first fraction, I see that it does have K. It has 1. We need K squared, and then it also doesn't have an A. So I'm going to multiply it by AK over AK. And then M times AK is AMK. Then we have minus, and I'm going to look at the second fraction. And my second fraction's denominator is 1. That tells me it's going to be missing everything. So AK squared over AK squared. And multiplied by B is going to be AB K squared plus. And I'm going to look and see what the second fraction is, or the third fraction is missing. And I see that it's not missing anything. So multiply by 1, and I just rewrite the numerator. And we look in our numerator and make sure that there are no like terms. In this case, there aren't. So we're done. The second concept in this lesson is talking about inscribed angles. So we have been working up until this point with central angles, meaning my angle is taking place at the center of the angle. But an inscribed angle is when it is happening against an outer part of the circle. Okay, so let's say that these two, if I was to do this part, this would still be 44 degrees. But its inscribed angle is actually going to be half. So the rule that we use with inscribed angles is their measure is half of the central angle, and these two are equal to each other. They may not look like they're drawn to scale to be proportional, but let's just go with it and say, yes, these are drawn perfectly even. So an inscribed angle is going to be half the measure of the central angle. So in our practice problem, we have an inscribed angle of 40 for this circle, and our problem is wanting us to solve for x. We know that the measure of this full circle is going to be 360 degrees. We know this part, we know this part, we can add those together, but we're still needing to know what is the measure of this part. So if we know that the inscribed angle is 40, the central angle, also the arc, is going to be 80. So now that I know that piece of information, I can add all 3 of these together to solve for 360 degrees. So we're going to add like terms, and 5x plus 7x is 12x, and then 40 plus 80 is 120. Equals 360. We're going to get rid of 120 by subtracting it from both sides. So 12x equals 240. Then we're going to divide by 12. And x equals 20. And we're done. We just found what they wanted us to find. We solved for x. Well, that's it for this lesson. Inscribed angles, and then also adding fractions. Be sure that as you're working on your homework, you're making notes of what you need to be getting extra help with in class. Make those notations so that whenever we do have question days, you guys are able to utilize that time to its fullest. I'll see you guys in class.